Hello! Today I'll be going over problem 2-sum. It reads as follows. Given an array of integers nums and an integer target, return indices of the two numbers such that they add up to target. You may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. Let's take a look at the example here. In this array, the first two elements, that is 2 and 7, add up to our target of 9, hence we return their position, which is 0 and 1. And remember, arrays start with the 0th index, which is the first element's position. So because nums of 0, which is the first element, and nums of 1, which is the second element, they add up to our target of 9, we return their index position, which is 0 and 1. And the next examples are similar. We have 2 and 4 adding up to 6, so we return their indexes. And we have 3 and 3, and they add up to 6, so we return the index of those. And notice here, 3 and 3, although it's the same digit, it's not considered the same element. It is the same element in terms of the mathematical value, but it is a different element because it's at a different position in the array. So that is allowed. Now, I like to demonstrate my approach. So I want to start looking at an example array. So I have an array here, A, I'm calling it. I have 4 numbers, and my target is 8. And my output is the index of the two numbers adding up to my 8. In this case, 2 and 6 would add up to 8, so I would return the index, the second index and the third index, which is 1 and 2. So my approach is that I want to do a computation, basically, which is target number, which is 8, minus the current element that I would be at. So if I'm starting out, I would do the computation 8 minus 1, and I call that computation counterpart here. So 8 minus 1, 7. So what does that number represent? Well, it's basically checking in my dictionary, which I'll explain in a moment. It's checking whether the dictionary of 7 exists or not. And the dictionary of 7 basically would be the index of a 7, if 7 at all exists in my array. And we know, because I have given the array here, there is no 7 in there. So the dictionary of 7 would not exist in the array. If it does, what it would mean is that we have found a complement along with the current element we're on. We have found another complementary number to add up to our target number. That's what the computation and my strategy is doing, is that take the target number and subtract it from the current element that I'm on. And if that number, the other number plus the current element I'm on, if that adds up to the target, then I have found my two numbers adding up to the target. I have found my 2-sum. In the case it doesn't, I move on to the next array and do the same until I reach the very last element. And if I have not found an element adding up to the sum, the target, then there is no pair of number adding up to my target. So let me explain what's going on here. I have a variable dictionary, which is a basic declaration of a dictionary or a hash map in JavaScript, and I have a basic for loop, and I'm starting from the first element until the last element. And what I'm doing is insertion and iteration. So what I mean is I'm iterating one element at a time. I am traversing the array, and I'm inserting into my dictionary the element and its index. So for example, the first element 1, its index is 0. So when I say dictionary of 1, it would be 0. Because dictionary of 1, that denotion is a key, and what dictionary of 1 would look for is the other number stored in the dictionary with number 1, which is 0, which is the index of my element. So what I do is I insert every time I iterate an element, and then I insert that element and its index. So I have my iteration, for example, I equals to 0, I'm at 1, and the counterpart, like I said, t minus a of I. A of I is right now 1. So 8 minus 1 would be 7, and because I don't have a 7 in my array, it would not be in the dictionary. If dictionary of counterpart does not equals to null, this is my if condition. Right now it would equals null. I don't have a dictionary of 7, so it would be null. So because this condition is not met, I don't go into this condition. I simply insert my element 1 and 0 into my dictionary, and then go on to the next element. So that brings us to I equals to 1. When I equals to 1, it indicates to the element here 2. So again, we do the computation target minus a of I. So target is 8 and a of I is 2. So 8 minus 2 is 6, and looking here we know that we have a 6 in the dictionary. So that means we have a 6 in our array, so that means it has to exist in our dictionary. So dictionary of 6 would be 2, which is its index position. So what I do here is, if dictionary of counterpart does not equal null, again what it means is that in fact that complementary number along with 2 exists in our dictionary. And if it does exist, hooray! What it means is we've found our complementary number along with the current element adding up to our target. So all we do is return out of our program immediately with this, with I, which is the current element, its index, the current element's index, and the dictionary of counterpart, which is basically the index of the complementary number that we found. So in this case, what we would return is index of 2, which is 1, and index of 6, dictionary of counterpart, that is dictionary of 6. Dictionary of 6 is 2. And see, 0, 1, 2. So we would return 1, which is index of 2, and we would return 2, which is index of 6. So that's what you would return. And that's basically what it is. In case we don't find, like I said, any pair of any 2 numbers pairing up to add up to target, then we simply return an empty array. And the order of the index numbers, whether you put dictionary of counterpart, comma, I, or vice versa, it doesn't matter. The order of the indexes that you return doesn't matter. Now the time complexity approximates to O of n, and so does the space complexity. So let's run the same code on LeetCode. Okay, so we're given the array 2, 7, 11, 15, and target is 9, and because 2 and 7, the first 2 elements, add up to 9, we return the indices of those 2 first elements, which is 0 and 1. So output expected matches. Let's submit. And there you have it. So if you have any questions or further clarifications, please do address them down below, and I'll be sure to get back to you on that. And please subscribe if I was relevant and helpful. It helps me generate better content and more content more often. Thank you.